We're solving problem 17 from the 2021 AMC 12A. Trapezoid ABCD has AB is parallel to CD, CD is 43, and AD is perpendicular to BD. Let O be the intersection of the diagonals AC and BD, and let P be the midpoint of BD. Given that OP is 11, the length of AD can be written in the form m root n, where m and n are positive integers, and n is not divisible by the square of any prime. What is m plus n? So here we have a depiction of this trapezoid as shown, and these are all the segments that break it up. So first thing we can do is assign variables to each some sides to show because we need it to represent things. First, let's let CP this length equal y, and similarly DO equal x. And let's see here. If we observe the triangle DBC, since it has two equal sides, it is an isosceles triangle, and by that, when the midpoint splits two segments, or when a point is drawn from the perpendicular of this angle bisector from the top, these two segments are equal. And since we are given that the segment PO is 11, we can write like an equation or an expression to express this certain case. So we know that DO is x, and we wanted to set it as x because it's important in our solvings for this problem. So DP is the one side is equal to PD because it's the other side from this segment CP, which separates it, and it is ultimately the length of 11 plus x. Because we know that this side can be represented as the quantity 11 plus x, this side must also too. Because again, it's an isosceles triangle. And since we see this similarity here, we also have CP as y. And what we can really denote is we see a lot of right triangles because this point goes down to the segment DP. This is a right angle there. So we can use the Pythagorean theorem because we have all variables for this triangle PDC. So therefore, one of the sides, 11 plus x squared plus y squared is equal to 43 squared. Now, is there a way we can solve for one of the variables at hand? If you look at the variable x denoted right here and y right here, since it has these sides, we can use similar triangles to determine that x is proportionate to something or something like that, because that would greatly help us if we could do that. And well, we see this big triangle ADO, and x is the horizontal component of that, which is fundamentally important because we're trying to solve for this segment AD. We realize that triangle CPO is similar to this triangle ADO, to the triangle ADO with x at the base, with a ratio of 1 to 2. So since we have that, what we can do now is, well, we know that this is 11, the base side, and we also know that the other base is the length x. So we can already get a value of x. X is equal to 11 times 2, or 22, because we know it was a ratio of 1 to 2. So you get this base length and then multiply it by 2 to get our bottom length for this triangle, and this works because they are similar. So we can then take this equation and rewrite it. This becomes 33 squared plus y squared is 43 squared. This means that y is equal to the square root of 43 squared minus 33 squared. We can then solve for y. After simplifying this to the fullest, you get that this is 2 root 190. But this is the value of this segment right here, CP. So, and we want to get the value of this segment AD. And how does this help us at all? Well, earlier we proved or shown that these two triangles, CPO and ADO, are similar with a ratio of 1 to 2. Therefore, since y corresponds to the side AD, we multiply our value of y by 2 to get our answer of AD is 4 root 190. Now, what the problem asks for is the sum of the expression of the length of AD, which i.e. m root n, where we have found that the sum we want is 4 plus 190, or 194. And that is our answer for this problem.